Hi guys, welcome to my channel. In this advanced series lectures, today we will see ByteStream classes. So ByteStreams are nothing but these are the streams by which we can read or write data byte by byte to or from the stream. So ByteStream classes provides mechanism for input and output of bytes. Byte streams are defined using two abstract classes at the top of the hierarchy, input stream and output stream. So even though I am saying that these byte streams, these are the classes by which it is possible to read byte by byte data or write byte by byte data or read or write byte by byte. So it is not possible by using a single class. So depending upon the source, whatever we are using, related class we have to create object of that related class. So there is huge hierarchy. So for that hierarchy, the topmost two classes are input stream and output stream. Both of these classes are abstract classes. So abstract class means what? This is a class which is used to provide only functionality for the derived classes or for hierarchy. Abstract class is never used to create object of a class. So for ByteStream classes, mainly there are two abstract classes in hierarchy. One is input stream and another is output stream. So first we will see hierarchy for input stream classes. So the topmost class, definitely the root class for input stream classes hierarchy will be input stream. So this is our abstract class. From this input stream class, from this root class, several classes are derived like file input stream, object input stream, pipe input stream, sequence input stream, filter input stream, string buffer input stream, byte array input stream. See, all these are classes which are used as input stream. That means these classes are used to read data from input stream. Only the difference is that for the different types of source, the related class object we have to create. For example, a file input stream, this class is used to read data from a file. So like that, different classes are available. In detail we will see later. First we will just look at the structure. Let me continue. So here filter input stream, this is again one abstract class and which is further inherited by several classes like data input stream, pushback input stream, buffered input stream and line number input stream. So these all are the input stream classes which are used to read data byte by byte from input stream, and that input stream can be any, just like file, object, pipe. We will see in detail very soon. So like this, like input stream hierarchy, we are also having output stream classes. Again, set of classes hierarchy is present. Definitely again, root class is output stream class, which is further inherited by several classes like file output stream, object output stream, pipe output stream, filter output stream, byte array output stream. So again, filter output stream is abstract class over here which is further inherited by data output stream, print stream and buffered output stream. So these are set of classes related to input stream and output stream. So now we will see use of these classes. So here is use, class and purpose. So first, buffered input stream. Here purposefully in pair the names of classes are taken, one from input stream and another from output stream. In pair it is taken, uh, which will become easy for understanding. So first, buffered input stream. It is used to read bytes from stream and buffer. So if we are using class buffered input stream, we will be able to read data byte by byte from a buffer. If we want to write into a buffer, we will use class buffered output stream. So this buffered output stream is used to write into a buffer. So buffer will be your stream. So buffered output byte stream means writing in a buffer what we want to output. Next, byte array input stream. So here source is byte array. That means we are reading from byte array. So it reads from byte array. Opposite to that, output stream. Byte array output stream. See, all these are built-in classes. Everywhere the conventions of Java is used while giving name to the class. So class name starts with capital letter. If there are multiple words, every new word is starting with again a capital letter. So I repeat this convention because it will be easy to remember or use these classes at the time of program. So byte array output stream, this is used to write into byte array. So writes to a byte array. So here for output stream, destination will be byte array. Data input stream reads standard data type. So in last lecture also we have discussed this point. So whatever the data we are going to read from input devices, this will be in the form of zeros and ones. So we want to have this data in the related primitive data types, and here this class data input stream helps to read data in the standard data types. If we want to write data in standard types, we can use data output stream. So here data output stream is used for writing standard types. Means we will be able to write data like int, float, double, char, string, like this. File input stream, here source of the data will be file, so reads from file. File output stream, destination is file because we are using output stream, so writes to a file. Input stream and output stream, these are abstract classes which are used to provide functionality to derived classes. So here it is simply written, these are abstract classes. Pushback input stream, it returns a byte to input stream. Random access file supports random access of a file. So if we want to access file for us with a specific record, we can use this random access file. It supports random file access. Print stream, output stream containing print and print ln. So in Java program, number of times we have used print ln. So from where it is coming? It is coming from the class print stream. So here the functions print and print ln are written. Object input stream, this class will allow reading of objects. So here source will be object. Object output stream, here the source or here the destination will be object. It will allow writing objects to stream. Pipe input stream represents an input pipe, whereas pipe output stream represents an output stream. So these are classes which we have seen in hierarchy for input stream and output stream. So these are some important methods which we need to use with a class, whatever we are using from input stream. So these are input stream methods. So listen, all of these methods are instance method. How I identified this? Because there is no static keyword, that means it is not a static method or it is not a class method. It is a instance method. All these methods are instance methods. Means what? If I need to call this method, I require object of a related class. So it is said that these are input stream methods. That means these methods are available in the root class of the hierarchy. We can go back. So here in this root class, these methods are available. As here is hierarchy, means what? From any of the class, we can access these methods. If I want to access these methods by using file input stream class object, I have to create object of this file input stream class and then I can call read method. I can use object input stream class object and I can call these methods. So any one of the class you can use to create object, and you can use all the methods which are defined under input stream. Again we will go to that slide. So come back. Okay. So int read. What it means? First, it is instance method. We need instance to call this method. It has no parameter. Return type is integer. So it is used to return an integer representation of next available byte of input. So as we know that this input stream class is under ByteStream classes. Means we are reading data byte by byte. So when by using object we will call this method. For example, if I say obj is my object of a class, suppose file input stream or object input stream, whatever it is, obj is object of one of the derived class, and I am calling method read. Means what? This method read byte by byte data or 1 byte of data from the source. If it is a file input stream object, from file it will read 1 byte of data. So whatever the data byte has been read, its integer equivalent will be returned. So return is integer. Okay. Second, read byte int read in bracket byte buffer array. Means what? Here we can read group of bytes as per the length of array buffer. Here buffer is array of bytes. As per the size of this buffer, that much number of bytes at a time we can read from the source. Let us consider size of this buffer is of 5 bytes. That means 5 at a time we can read 5 bytes. So if we are using here, let us consider again I am using. So if I write obj dot read, I am taking same array name buffer. So let us consider buffer is already defined array, and in this array buffer Okay, I define here byte buffer. I'm using simple editor. I'm not using now your NetBeans. Just for example, I'm using taking one editor, notepad. So byte buffer equals to byte buffer. Let us consider I'm using sunset byte. So let us consider byte array is created, byte buffer with size as 5, and here I am using obj is it is considered object of some input stream class, maybe a file input stream or whatever. Obj.read buffer, that means at a time here I can read 5 bytes of data from a file or from a source for which I have created object. At the end of stream, I get return value as -1. That means -1 indicates that there is no more bytes available in source. If I am using this second read method where argument is of byte buffer, so here return type will be the number of bytes that has been read successfully by using method. If there are, even though the size is 5, but let us consider only 5 bytes of data is available, return will be 4. Next, let us consider I am having too much big buffer in which I can read number of bytes of data from the source, but while reading the data I want to specify from which index or from which element up to how many number of bytes I want to fill up this array. So I can do this. So for that, here is read method. Int, that is return type is integer, method name is read. Byte buffer, again here we have to specify whatever the byte buffer we are having or byte array we are having. Next, in offset, it means that from which element or from which index location you want to start reading into buffer. And int num bytes means how many number of bytes you want to read. So it attempts to read up to num bytes into buffer starting at buffer offset, returns actual number of bytes that are read. At end returns -1. Again, I can give you the same example. Let us consider here I am having array size of byte buffer is suppose 10. I am starting from the memory location. I type here again. If I am writing, I edit the same statement. If I write like this, 1, comma, suppose 4, here I make size as 50. Let us consider array of 50 bytes I am having as buffer. I am using this array. I don't want to fill up data right from the first location of array. Here I am specifying it 1. We all know that array index always starts with 0. So 1 means from second position in array, it will fill up the data. It will take the data in buffer, and after that 4 bytes of data it will read into the buffer. That means from 1 index 1, after that plus 4 data items, that means at buffer of 1, buffer of 2, buffer of 3, buffer of 4 and buffer of 5. This will be your data which are taken in buffer array. So this 4 indicates num bytes, 1 indicates starting position where you are reading into the buffer. So like this we can also use. And what is the return value? How many number of bytes that has been read successfully, that is a return. So if there, even though you are trying to read 4 bytes but there are only 2 bytes available in source, only here the return value will be 2. Void close, again instance method. All these are instance methods. So close input stream. Once we have finished our work with input stream, it is better to close that stream for safety. So we can use close method. So let us consider obj.close. So it will close input stream whatever we are using. So like this we can use, if obj is my object of any input stream class, maybe suppose file input stream, I can close it like this. So like this I can use this method. These are some more input stream methods. Long, skip, long, num bytes. While reading data byte by byte from source can be any, maybe object, maybe file, maybe sequence, maybe pipe, whatever it is. So while reading the data, it always take data byte by byte, right from first byte up to the last byte, sequentially. If some bytes of data we want to skip while reading, we can use this method skip. So skip, in bracket you have to specify how many number of bytes you want to skip. So it skips number of bytes. So for example here, if I am writing obj dot skip, I write here 2. It means that, let us consider third byte of data we are reading. Okay, here I have written 4. Fifth byte of data we are reading, and here suddenly the method is coming skip 2. Means it will not read fifth byte and sixth byte. 2 bytes are skipped, and after that whenever there is a read method call, it will take read operation for next byte, that is 8th byte of data. So 2 bytes of data we are skipping over here. So this argument indicates how many number of bytes you want to skip from reading. Next, available method. So definitely here by using skip method, whatever the number of bytes you have skipped, so as per that, that number will be returned. Int available. Return type is integer. It returns the number of bytes currently available for reading. So we can say that it can tell us what is the size of our data, whatever source we are using. So whatever the size of the data, that is how much number of bytes are available for reading. So for if I am using obj.available, I will get how many number of bytes that are available to read. Word mark. It is just like a bookmark. While reading a book, we used to keep some bookmark, and later when we want to continue from that bookmark, we can be. So if we want to put some bookmark, or we want to put some mark in our data source, in our input stream, in our data source, we can put the mark, and we can specify up to how many byte reading we want to keep this mark there as it is. So that can be done by using mark, and inside mark as a method, and inside this argument we can specify the number of bytes. If I am keeping here number of bytes as 10, that means to the current position of the data source, whatever the byte where the current position is there, or the cursor position is there in the data source, so there the mark is placed, or you can say bookmark is placed, and after, if I am giving the argument as 10, up to reading 10 bytes of further data, that mark will remain as it is. So I can specify up to how many number of bytes that mark should remain present. So that is the use of mark method. Place a mark at current point in input stream and remain valid till number of bytes are read. Word reset. If we have kept some marks in our input stream by using such methods, and we want to erase these marks, we can say, or we want to move back while reading. We want to move in back direction up to the mark position, we can say. So we can reach to that mark position while reading by using reset. So it resets pointer to previously set mark, goes back to stream, otherwise goes back to stream beginning. So if I kept a mark at suppose fifth byte in input stream, I am reading suppose 7th byte, and I call reset method. So immediately pointer will take the position to byte 5 because the mark is available. If the mark is not available and still I am using reset method, then cursor or the pointer will place to the beginning of the input stream. So that is the use of reset method. Some output stream methods like input stream, we are having output stream methods also. So again, in the hierarchy, topmost class was output stream. So here output stream class is abstract class. It is providing only functionality to down level classes or derived classes, and these all are the functions which are available in output stream. So by using any of the output stream derived class, in this hierarchy, any of the output stream derived class, we can create object, and we can call any of the method. Definitely depend upon the destination. Here I say destination because we are using output stream. Depend upon the destination required. If you want to write into the file, definitely we have to create object of a file output stream class. So depend upon the destination, we have to create object of that related class, and by using that object we can call these methods. So first, write. So it is used to write a single byte of data in your output stream. So writes a single byte to an output stream. Just as we have called methods for we have called methods for input stream. So just like that we can call here. Let us consider my OP-OBJ output. This is my object of output stream. I am using here write. I am using here write operation. So what it means, 1 byte of data will get read, will get write in your file. So this argument is of type integer. If we want to write at a time more number of bytes, so for that we can use buffer as we had used with read operation. So here write byte buffer. So as per the size of buffer, entire buffer you can write to your output stream. Writes an array of bytes to an output stream. So if buffer size is 5, all these 5 bytes you can write at one time to output stream. If the size is 10, at a time you can write 10 bytes to output stream, like this. Another overload is also available with write. So if the size of buffer is a big one and you don't want to put up or don't want to write the entire buffer or array byte of array in your output stream, selected part or sub array, you can say sub range of bytes you want to write into output stream, you can use this overload, which specifies that here you will specify array bytes, just like here buffer, here you will specify. Then as a second parameter we will specify offset, that is the beginning or from which index within the array you want to select the data for writing. And here third parameter, that means number of bytes, how many number of bytes we want to write. For example, if I write here, again I use OP-OBJ, output stream we are using. For that the object, let us consider OP-OBJ. Here I write operation, write method. Let us consider again I am using buffer as my array of bytes. I use, here I write 2, my index position is, let us consider 2, and here I write 5. What it means, it will write elements starting from index position 2, that means 0, 1, 2, that means from third element it will start writing data to output stream byte by byte, and total 5 number of bytes it will write to output stream. That means element at index 2, then element at 3, element at 4, then 5, then 6. Up to that it will write byte by byte. Total 5 bytes it will write to your output stream. For output stream again the close method is available. So once the use of output stream is over, you can use close method, just like OP-OBJ.close, it will call close method, so it close the output stream. And flush clears the buffer. So whatever the buffer we were using for output stream, that our buffer will get clear after calling flush method. So these all are about input and output streams, different classes and commonly used methods. So in program we will use these methods. So I hope you understood. Thank you. Keep watching.